Okay, this is find the difference quotient, and you will be given this formula on the test. So the first thing we want to do is find f of x plus h, which remember means just put x plus h in for x. So we go 3x plus h plus 2, and then we get 3x plus 3h plus 2. And so there's f of x plus h, and here's f of x. So we're just going to put it in here. So f of x plus h is 3x plus 3h plus 2 minus 3x plus 2 over h. If this whole thing doesn't cancel, you did something wrong. So now on top, I have 3h over h, and my difference quotient, or what means rate of change, is 3, which we already know it was because this is linear. But now this one is not linear, so it's not just going to be a constant. There's going to be variables in it. So when you do x plus h squared, make sure you do x plus h times x plus h, which is x squared plus 2xh plus h squared, and then don't forget the plus 3. So there's my f of x plus h. Here's my f of x. I'm going to put it into the formula again. X squared plus 2xh plus h squared plus 3. And remember, you'll be given this formula. Minus x squared plus 3. And then don't forget all over h. Now watch. This cancels and this cancels again. So now I'm left with 2xh plus h over h. And I can take an h out of the top here. And then the h's cancel. And my answer is, whoops, that's h. 2x plus h. Okay. The next one on page 1 is these three are graphing. I want you to notice the transformations or translations here. This is 2 to the right and up 3. Well, it's really helpful if you remember the shape of the graph. So I'm going to go 2 to the right and up 3. And then if you remember the pattern for square root, it's 1, 1, and 1, 3. You can just do that. But if you don't remember the pattern, just do this. I can't put anything. I can put a 2 in there and get root 0, and I get 3, and that's the point I started with. But I can't put anything less than 2 because it makes that negative. So if I put a 3 in there, it's 3 minus 2 plus 3, which gives me 4, which is that point right there that we knew from the 1, 1. Now the 1, 3 comes from, I don't really want to put a 4 in there because then I get root 2. Put a 5, I get root 3. So I go to 6 where I get root 4, which is 2 plus 3. And then I get 5. And so that's where I get the 6 and the 5. And then just graph it like that, and you've got the square root. This one is a parabola. Remember, the parabola looks like this. The pattern for that was 1, 1, and 3, 1. But again, if you don't remember the pattern, you can just use a table. So now my translations are 1 to the left, because remember this lies, and 3 down. So it's negative 1 and 3 is where I start. But now I have a reflection because it's negative and a stretch. So instead of going 1, 1, I'm going to go negative 2, 1, negative 2, 1. And then instead of 3, I do negative 6. But we're out of graph here, so here's my parabola. Now if I forget the pattern, again, just make a table and do this. Now, I have my negative 1, 3 here to start with, negative 1, negative 3. So I want to go on either side of this negative 1. So I'd put a negative 2 and a 0 in. So negative 2 plus 1 is negative 1 squared. So that gives me negative 2 times 1 minus 3, which gives me negative 5, which is what I got right here. And then if I put 0 in, I get negative 2 times 0 plus 1 squared, which is negative 2 times 1 squared. See, the 1 squared and the negative 1 squared give me the same thing. And that's why these points are the same and they reflect on each other. Now, if you needed to, if the graph wasn't, we would go to positive 1 and go negative 2. And then 1 plus 1 is 2 squared. So I get negative 2 times 4 minus 3, which gives me negative 11. That's over here. But then remember, it's symmetric. So we really don't have to do both of these because they match each other. And then 1 would match over here with the negative 3. Okay, this one is absolute value. And it makes a V. And my translation again is 3 to the right and 1 up this time. So I go 3 and 1. And it's negative, so it's going to be going down. And it's 1/2. So it's going to be a shrink of 1/2. So it's going to make it wider. So I'm just going to do some, I'm not really a fan of the shrinks of 1/2. So I'm just going to put some points in here. And I'm going to put some points on either side of my vertex, which was 3, 1. Now I'd really like this to be even, so when I half it, it stays a whole number. So rather than put a 4 in there, I'm going to put a 5 in there. And that absolute value is symmetric, just like the parabola. So if I put a 5, it's going to give me the same as a 1. These two are going to give me the same values. Because look, 5 minus 3 is 2. And 1 minus 3 is negative 2, but it's absolute value. So I'm going to get the same value for both of these. 5 minus 3, absolute value is 2. Plus 1, see what I did? This makes a whole number, and I get 0. So at 5, I get 0. But guess what? At 1, I also get 0. And they just want you to graph 3 distinct points so we know what the shape is, so we just